this is a liquid and this is gas, right? Now can you just try to balance this chemical reaction?
Sir, it's already balanced, isn't it?
Oh, is it balanced?
Oh yeah. For oxygen, it's not balanced.
Yeah, oxygen is not balanced. So how can you balance this?
There will be 2 in front of H2O.
There will be 2 in front of H2O, and then
2 in front of H2O2.
okay, 2 in front of H2O2 also, right?
And that's it.
Yeah, right. So ultimately you can just count the number of oxygen here 4 and here also 2 plus 2 4. So a student adds powdered manganese
Sir,
oxide.
but in the reaction side,
Okay.
there will be 4 oxygen, right?
Yeah, there will be
2.
4 oxygen. This 2
Oh,
into
okay,
this
yeah.
2, 4. And here in H2O2 we have, in each H2O2 molecule we have 1 oxygen, but we have 2 H2O2 molecules. So altogether we have 2 oxygen from H2O, and O2 itself contains 2 oxygen atoms. So altogether we have 4 oxygen atoms in the product side also. Okay, right. So a student adds powdered manganese oxide to aqueous hydrogen peroxide in a conical flask as shown in figure 4.1. The mass of the conical flask and its content is measured at regular time intervals. The mass decreases as time increases, right? So when you are reading the question, you should get some idea. In a chemical reaction, the mass should be conserved, right? So the mass should be conserved mean the mass of the reactant should be equal to the mass of the products, right? So in a closed system, we can experimentally demonstrate it, right? But now you see here, if we weigh the weight of the mass of the contents, now here they are telling the mass decreases, right? So if the mass is decreases, what happens? Do you have any guess?
Time increases.
No. When the time increases, the mass of the content, right? So the mass of the content, which means
so the reaction will.
Yeah, now you see here H2O2 has a weight, right? So H2O2 has a weight and MnO2 has a weight, right? So now what will this balance read? The weight of conical flask plus weight of H2O2 plus weight of MnO2, right? So at the end, the weight of MnO2 will not change because this is a catalyst. So at the end of the reaction, catalysts are not used or consumed, right? So this will not change. And the weight of the conical flask also does not change. And weight of the H2O2 also should not change. But at the end of the reaction, what happens? It transforms to H2O and O2, right? So now you can tell that the weight of the H2O2 is equal to weight of the water and weight of oxygen gas, right? So weight of H2O2 is equal to weight of H2O plus weight of oxygen gas. Now you see here, since we are using this conical flask and we don't have any hole through which the water can flow, but still the weight of the content is reducing. So what can be the cause? Now you see here, if you look at this label diagram, they are telling loosely fitting cotton wool plug, right? Which means loosely fitting means there might be some gaps in the stopper of this mouth, right? So the mouth of the stopper, the mouth of the conical flask has been stopped using this loosely fitting cotton wool plug. So there may be some small gaps, through which the oxygen gas may escape. Can you understand that? So if the
Yeah.
oxygen gas escapes to the environment, what will happen to the mass of the entire content?
It will collide.
It will reduce. It will reduce. The mass of the entire content will reduce since the oxygen gas escapes through the gaps available in the loosely fitting cotton wool plug. Right? Now, this is what they are asking in the first part. State why the mass of the conical flask and its content decreases as time increases. Why? Because the formed or decomposed oxygen gas may escape through the gaps in the loosely
Particles of hydrogen peroxide are closest together at the start,
I'm
increasing collision. Particles of hydrogen peroxide are closest together at the start, increasing collision.
what are you telling? Is
In the
that
answer,
in the
yeah, over here in the paper, the answer is that the particles of hydrogen peroxide are closest together at the start, increasing collision.
for the first one? That's not the
Yeah.
answer for the first one. Yeah, you see.
Oh,
No, that's not the answer for the first
Yeah, yeah.
one because we are not going to talk about the collision theory because for the reason why the content of the weight of the content is decreasing.
so for the first one, the oxygen formed